All right, well, welcome to our second midterm review night. I've only got 4 questions for you tonight, but they're 4 big ones. So this first one is just subtract these two functions. Number 2 is actually solve for x. 3 is a nice probability. And 4, based off this graph, state the domain range. Is this a function? Is it a one-to-one function? And is it an onto function? And let's just make sure we answer why on these. Why would you say yes or no? Again, once you've got these 4 done, you've paused it, you've worked them out, go ahead through and see how you did. So question 1 here. When I first go to subtract, the first thing I'm going to do is I'm going to change that negative to a positive. And I'm going to make anybody after it negative. So let me be clear. If this was 24 minus 3x, it would then become negative 24 plus 3x. Make sure anybody over here changes signs. The next thing I need to do is find a common denominator, but you'll notice that this can get factored first. So I'm going to say this is x plus 4 and x minus 4. Okay, so now my goal is to write 2 fractions with the exact same denominator. Well, I want my common denominator to be x plus 4 and an x minus 4. So this first fraction, I don't need to do anything to. The second fraction, however, does need to change slightly. It only currently has x minus 4, and like we said, we want it to be x minus 4 and x plus 4. So it's missing the x plus 4, which just means whatever I do to the bottom, I need to do the same thing to the top. So now I'm going to take that negative 24 and distribute, and say negative 24x. A negative times a positive is a negative, and I get a negative 96. Okay, now that I have 2 fractions with the same denominator, I'm going to turn that into 1 fraction. I'm going to keep that common denominator, and I'm going to put any like terms together. The 12 can go with the negative 96. That gets me a negative 84. And then I'm going to have my minus 24x. Now, if I can go any further, I'm going to do that, and I can factor this numerator. I can pull out, let's see, a negative 4. And then I'm basically just dividing 84 by negative 4 and negative 24 by negative 4. So I'm going to get positive 21 plus 6x all over x plus 4 and x minus 4. Looks like I could have gone further. They're both divisible by 3 as well, so I can pull out a 3. So that's going to get me a negative 12 out front. 7 plus 2x all over x plus 4 and x minus 4. Now question 2 is slightly different. Although it looks almost the same, we added this equals 3 on. So that is going to change our problem just a little bit. So the first thing I'm going to do is factor the numerator or denominator if possible. And of course I can factor the denominator. I'm going to change this negative to a positive and make that bare negative on top. So I have plus a negative 24 x minus 4. And I've got this equals 3. Now this time when there's that equal sign there, my goal is to eliminate the fraction. Okay, so I'm going to multiply every term by the common denominator. Now we already know the common denominator is x plus 4, x minus 4. So every term gets it, and my goal is to eliminate the fraction. I only need to keep the fraction when I'm adding or subtracting. But this time there's an equal sign, so that changes it. Okay, so what cancels? Well, those disappear completely, and all I'm left with is the number 12, which is fantastic. These disappear completely, and now I'm going to have to multiply this times this. So I get negative 24x minus 96. Now, this third term we just have to be very careful about. Pick your favorite 2 terms and multiply them. Maybe these are your favorite 2 terms. So I'm going to scratch those off, and I'm going to multiply them, and I know I get x squared minus 16. Okay, now, again, those are gone. I got this x squared minus 16. Now I'm going to take this 3 and distribute it through. So I get equals 3x squared minus 48. Now I'll simply solve this equation. I'm just going to set it equal to 0. So I want 0 on one side and everybody else on the other side. So I'm going to add over my 24x. And let's see, let's put together our other terms. Let's see, I have a negative, and I think that gets me a positive 48. Okay. Now, I'm going to factor and clean that up. It looks like I have a GCF of 3, so I'm going to pull out my 3. I've got x squared, let's see, plus 8x plus 12. Keep that 3 in front. Let's see, I'm going to go x plus 6 and x plus 2. Tee it up. Now remember, you're setting each piece equal to 0. And just ask yourself, how many x's are there? Well, first of all, I only see 2 x's. That means this answer is going to get rejected because that doesn't make any sense. If I subtract the 6 over, I get x equals negative 6 and x equals negative 2. Now you do have to check, guys, and that's probably one of the most important things I could have done right from the beginning. The first thing I would do is look at this denominator and say, is there any number that makes this fraction undefined? Well, x cannot equal the number 4 because 4 minus 4 is 0. And then I'll look at this fraction and do the same thing. The only other number it cannot be is negative 4 because that will also give me an answer of 0. So if either of those answers come up, I reject them. Luckily, neither did, so I'm going to take both solutions, negative 6 and negative 2. All right, question 3, the probability of rolling exactly 3 4s in 5 rolls of a fair dice. Well, hopefully you boxed in that keyword there, exactly. That means we only have to write this formula out once. So we need to find a total and a want. So let's read it again. The probability of rolling exactly 3 4s in 5 rolls. So I'm going to roll this thing 5 times, and I want 3. Hopefully we're all on the same page there. I'm rolling a total of 5, and I want 3. Now, a success is getting the number 4. How many ways can you get the number 4 when you roll a die? Well, that's 1 out of 6. So if it can happen 1 out of 6 times, then it's going to fail 5 out of 6. Now, that probability formula should be the first thing you're writing on your paper. NCR, success to the R, failure to the N minus R. And we said there's a real easy way to remember it. The R's are touching both sides of this S. Okay, so keep that in mind. That R and that R have to be the same number. So I'm going to go 5C3. My success was 1 out of 6 to the third. Make sure they match. Then my failure is 5 out of 6 to the second. Type that in your calculator, and you've got an answer. Now we're going to go math fraction, of course. And I end up with 125 over 3888. Now, you always want to put a fraction unless it says round. That is the only time I'm not going to write a fraction down. All right, question 4, our last question for the night. Couple things we need to know about functions. So first of all, domain. When we hear the word domain, what pops in our head? Hopefully, you're saying the x values. So I'm basically going to look at the x-axis and see how far to the left and how far to the right does this graph go. So in this case, I'm just going to say from 01 to 04. I'm going to put a comma between them. Now I have to decide, do I want a bracket or a parenthesis? Well, remember, a bracket is for a solid dot and a parenthesis for an open dot. So I'm going to bracket in 01 to 04. Range. This time when I hear range, we've got to be thinking y values. Okay, so I'm now looking at the y-axis, my up and down values. And I'm saying, again, how low and how high does this graph go? So I kind of just look for my lowest, which looks like about there, my highest, which looks like about here, and just make sure you go in numerical order, lowest to highest. So my low would be 250, comma, my high would be 300. And then again, I just need to decide bracket or parenthesis. Well, this is a solid line, so everything there is going to be a nice solid bracket. All right, do I have a function? Well, when we're looking at a graph, what's got to pop in your head about functions? Hopefully you're saying the vertical line test. Does this pass the vertical line test? And basically that test says if you take a vertical line and you take this line and you move it left and right, is it only going to touch this function once? Okay, no matter where I draw this line, it should only touch once. Therefore, I would say yes, this is a function, it passes the vertical line test. Now, a one-to-one function, it has to pass both, let me repeat that, both the vertical line test and the horizontal line test. Okay, now we already know it passes the vertical, let's test the horizontal. Horizontal means I'm going to draw in a horizontal line, and it can only touch the function once. Well, I can clearly see that that fails because it hits 1, 2, 3 when I draw it that way. Even if I draw it here, it's going to hit twice. So I'm going to say this is no, and it fails the horizontal line test. Now, one-to-one. I haven't talked about that bear in a long time. So a one-to-one function is one that goes infinitely up and infinitely down. So basically, does this graph shoot up forever and shoot down forever? I would say no. However, if this graph kind of went up like this with an arrow on the end and down like this with an arrow on the end, then I would justify it as onto. But it did not look like that. This graph does not go up forever and down forever. Well, we've got 4 or 5 more questions tomorrow night, and we'll look forward to that midterm.